In order for us to understand how to interpret even or odd trig functions, let's just think about even or odd functions, period. What exactly is an even function? Well, an even function basically is a function so that if we input a positive value or if we input a negative value, basically we end up with the same answer. So this is what happens when we have an even function. For example, if we had the function f of x is equal to x squared, if we input a positive 5, we would end up with 25. If we input a negative 5, that's basically negative 5 times negative 5, or negative 5 squared, we would also end up with a positive 25. So in other words, whether we input a positive answer or we input a negative one, we end up with exactly the same value. If we have an odd function, though, what happens is that as opposed to the two answers being the same, if we input a negative value or if we input a positive value, they're going to be different by a factor of a negative. In other words, the only way we'd make them equal is if we multiply by a negative 1. So in other words, if the answer here for our negative answer is a positive 3, then the answer over here would be a negative 3. So let's look at an example. If you had, for example, let's say the function f of x equals x cubed. This is an odd function because let's say that we input f of negative 2. So what this means is we're doing negative 2 times negative 2 times negative 2, which gives us a negative 8. If we input a positive 2, now we're doing the same thing, but we're using 2 times 2 times 2. That's going to give us a positive 8. If you notice, our two answers really only differ by one of them being negative. In other words, they're opposites. So like we said here, if we have an answer here that's negative, this answer will be positive, or if this answer is negative, then this one is positive. So this relationship happens anytime we're dealing with an odd function. How would we express positive or negative angles? Well, let's say that we had to express 60 degrees, positive 60 degrees. What we say is we'd start here at 0 degrees and we would move a particular value and we would end up with an angle, forming an angle equivalent to a positive 60 degrees. But what if we needed a negative 60 degrees? So to get a negative 60 degrees, we'd have to move in the opposite direction. In other words, we'd have to move in the clockwise direction. So we'd say we'd still start here and we'll move in this direction. We'd form our angle. And so this angle is negative 60 degrees. So keep this in mind as we have our discussion of even or odd trig functions. So let's talk about the cosine function. Suppose that we had to find the cosine of 60 degrees. And let's say we want to compare it to the cosine of negative 60 degrees. And the reason why we're doing this is basically just to see if cosine would be an even or an odd function. So for the positive 60 degrees, we'd have to count basically this direction, our counterclockwise direction, 60 degrees. So if we remember from the unit circle, there's a point associated with that, and that particular point would be at 1/2 comma radical 3 over 2. But if we were to count in the opposite direction to get a negative angle, in other words, if we went this way out 60 degrees, this would correspond to our negative 60 degree angle. Our negative 60 degree angle corresponds to, or is coterminal with, 300 degrees. So you can check this yourself or look at one of the previous videos about coterminal angles that show why these represent the same angle. But in any case, negative 60 degrees stops here on the unit circle. So the ordered pair that we would have at that point, according to the unit circle, would be a positive 1/2, comma, a negative radical 3 over 2. Remember that in our ordered pair, cosine would be the first value and sine would be the second value. So cosine is what we're looking for. So what would the cosine of 60 degrees be? Since this ordered pair corresponds to our information for 60 degrees, the cosine of 60 degrees would be right there. It would be our 1/2. What would the cosine of negative 60 degrees be? Well, right here, this is our information or point for negative 60 degrees. So at negative 60 degrees, we can see clearly that the cosine, which is the first one, would be a positive 1/2. So what does that tell us? Whether we input a positive value or we input a negative value, we end up with exactly the same output. So it's like we said before, our function, whether we input a positive or a negative value, it's equal. This is the definition of an even function. So what does this tell us about cosine? Well, the cosine of a negative number, any negative number, is equal to the cosine of any positive angle measurement. And the reason is because cosine is an even function. So now let's talk about the sine function. So for the sine function, suppose that we were to ask the same question, sine of 60 degrees versus the sine of negative 60 degrees. So let's go back to those two values. So remember, for positive 60 degrees, we're counting in the counterclockwise direction. So at this positive 60 degrees, we know that we had the ordered pair or the associated point on the unit circle of 1/2, comma, radical 3 over 2. For negative 60 degrees, we're counting 60 degrees the other direction, in other words, our counterclockwise direction. And so this is what negative 60 degrees, our clockwise direction. And so this is what negative 60 degrees would look like. So our unit circle tells us that at this point, we would have positive 1/2 and negative radical 3 over 2. Again, remember how the ordered pair is set up. The first value is cosine, the second one is sine. So because we're evaluating sine here, we're looking at the second number. So if we wanted to find the sine of 60 degrees, again, this is where we're looking for 60 degrees. The sine is the second value. So the sine of 60 degrees is going to be a positive radical 3 over 2. For our negative 60 degrees, we know that this is where we would have to look. That's our point associated with negative 60 degrees. We're looking for the sine, and so the sine is this value here. So our sine would end up being negative radical 3 over 2. So notice what's happening here. If we input a positive value, we end up with a positive answer. If we input a negative or the opposite of that value, we end up with the opposite value. So it's like what we said before about this situation where if we input one answer and we end up with the opposite answer, that this is an example of a function that is odd. So in other words, the sine function is odd. So what that means is if you take any answer, so for example, let's say I know that the sine of something is equal to 4/5. And I said, what would happen if you input the opposite of that angle? Well, based on the fact that sine is odd, our answer has to be the opposite also. So it's going to be negative 4/5. Or if we said that, for example, the sine of positive pi over 4 was radical 2 over 2, then what would the sine of negative pi over 4 be? Well, because sine is odd, it would be the opposite of that answer. So it would be negative radical 2 over 2. Well, what about the tangent? So the tangent, as we know, is basically the sine of whatever the angle is divided by the cosine of that angle. So if we took our same two angles, positive 60 degrees, and we're just using 60 and negative 60. It really could be any angle to demonstrate this point. But at positive 60 degrees, we said that, again, our ordered pair was 1/2 and radical 3 over 2. At negative 60 degrees, we said that our ordered pair was positive 1/2 and negative radical 3 over 2. So let's say that we wanted to find out what the tangent of positive 60 degrees was, and we want to compare that with the tangent of negative 60 degrees. So we would need to know what the sine of 60 degrees is and put that answer over the cosine of 60 degrees. Similarly here, we need to find out what the sine of negative 60 degrees is and put that answer over the cosine of negative 60 degrees. So we know from the previous example that the sine of 60 degrees was, what was it? It was radical 3 over 2. And the cosine of 60 degrees, that's going to end up being 1/2. So if we divided everything, you can check it yourself, we're going to basically end up with radical 3 over 1. Basically, those denominators, because they're the same, they're going to eliminate. So if we continue the work on the other example for sine of 60 degrees, sine of negative 60 degrees, from the previous example, we had negative radical 3 over 2. And cosine of 60 degrees is positive 1/2. So if we simplified everything, we would end up with a negative radical 3 over positive 1. So let's compare the answers. We have one answer being radical 3 over 1 and the other as negative radical 3 over 1. What does that tell you about the tangent function? Well, these answers are not equal. So that means that our function is not even. It's an odd function. So in other words, if we input a positive value or if we input a negative value, the two answers that we get are opposites of each other. So tangent is an odd function. What does that mean? That means if we know that the tangent of, let's say, some angle theta is equal to 3/5, the tangent of negative theta would have to be the opposite of that because it's odd. So the answer here would be negative 3/5. So what if we had tangent of pi over 4? Well, you can check this yourself, but the tangent of pi over 4 is going to be 1. So what does that mean for the tangent of negative pi over 4? Well, because tangent is an odd function, we know that the answers here have to differ by a factor of negative 1. In other words, they have to be opposites. So this would have to be negative 1. So far we know which functions out of sine, cosine, and tangent are going to be even or odd functions. But how does this affect our reciprocal functions? Well, let's think about how reciprocal functions work, period. So let's say that we took a function f of x, which is x squared. Its reciprocal function, let's call it g of x. Its reciprocal function would be 1 over x squared. In other words, we're taking x squared over 1 and we're doing the reciprocal to make it 1 over x squared. So f and g, these two functions are reciprocal functions of each other. So if we recall, if we input a negative x here, then we're basically squaring something that's negative, and we're going to end up with basically the same answer. So we know that x squared, this is an example of an even function, because if we input a negative or if we input a positive, we end up with exactly the same thing. So let's think about g of x here. Let's say that we input g of negative x. So we're basically doing 1 over negative x squared. So what that means is that we're doing 1 over negative x times negative x, or basically 1 over a positive x squared. So if we input a positive value or if we input a negative value, we end up with exactly the same answer. So again, that tells us that the function g has to be what kind of function? It has to be an even function. So what does that tell us? Well, basically, if you have a function or its reciprocal function, if you flip it, in other words, if you make one the reciprocal of the other, that it's not going to change if it's even or not. If it started out even and we did the reciprocal of it, it's still even. This works even if we're dealing with odd functions. So if we have 1 over x cubed, this is the same as f of negative x would be the same as negative x times negative x times negative x over 1, I'm sorry, under 1. A negative times a negative is a positive, and multiply that times this negative means that our answer here is going to be negative in the denominator. So when we compare what we started with what we end up with, clearly these are opposites of each other. So what does that say about the function f? Like we said before, f has to be an odd function. So this happens when we're dealing with an odd function. So we already knew that if we did g of x equals x cubed, we did this at the beginning. Turns out that this is also an odd function. So like we said, it doesn't matter if we flip the fraction or not. It does not matter if we flip the function or not. If it started off odd, it's still going to be odd. So let's think about what that means for our basic functions. So sine, cosine, and tangent. The reciprocal function for sine is the cosecant. And the reciprocal function for cosine is going to be the secant. And the reciprocal function for the tangent is the cotangent. So in other words, if sine is opposite over hypotenuse, then cosecant would just be hypotenuse over opposite. And if cosine is adjacent over hypotenuse, then secant would be hypotenuse over adjacent. And tangent is opposite over adjacent, but cotangent would be adjacent over opposite. We're basically just doing the reciprocal or flipping the fraction. What do we know about these functions? Which ones are odd and which ones are even? Well, we know that cosine is even. And we know that flipping it does not change that, so that means that secant also has to be even. We know that sine was odd, and we know flipping it does not change it, so cosecant is also odd. Tangent was odd as well. Flipping it does not change it, so cotangent is still odd. So we can apply these relationships to basically simplify or work out some problems, but it's just good to know which functions are even and which functions are odd.